Prego.
Good morning, everybody. Buongiorno a tutti. It's really a pleasure and an honor for Leonardo and for the US business of the Leonardo Aircraft Division that I'm representing here, together with Antonio Vento, system engineer from the EUDAS project. It's really an honor and a pleasure to be hosted in such an important event. The only regret we do have, we cannot join also the nice part of the of being in Puglia, which is always a nice place, always, and apart from the fantastic job you're doing within this Grottaglie event. Okay, I'm sharing the presentation, if it works. Okay, so we will make a very short introduction about what are the main issues associated with the current Airpass accommodation into the airspace, including background on how we are dealing with the civil and military authorities for this task, based on our experience with the Falco Evo and Falco Explorer, and respectively in Lampedusa and in Sicily. Then we will try to give you a very short brief about detect and avoid development as a key enabler for this Airpass accommodation. The detect and avoid are still considered an aid at the moment, but is becoming a critical component for maintaining safety US missions in the same airspace with manned aircraft. And last but not least, the important role of Europe, in particular of this EUDAS project, into this job, and why, as a Europe as a whole, and Italy is pushing a lot as well, we are investing so much effort in this development, in such a complex development. Okay, for what concerns the Airpass accommodation, this is becoming an increasingly important topic in aviation, since we have a huge increase of the need for performing missions integrated with other aircraft, either cooperative and non-cooperative, into the airspace. And I mean all the classes from A to G, so from controlled to uncontrolled airspaces. So at the moment, it's quite a complex task to activate such kind of missions, which is based on a case-by-case safety risk assessment of the intended concept of operation. And also, we need to, of course, to comply with communication, navigation, identification, and surveillance requirements, where we are intending to use the UAV system. The flight plan also must be in adherence to the ICAO Annex 2, so to the rules of the EASA. But being the last two bullet points, last bullet points, quite an easy task, since they are the same for the use for manned aircrafts. The first one is hampering the possibility to perform flexibility missions of US systems, since it requires a quite important preparatory work before starting the activities. So on top of these elements, we do have now the detect and avoid solutions. Non vedono le slide. Oh. So I hope it's
okay.
It's better now. Okay, so I saw that's not the nicest way to display, but I keep this this way in order to support the better support the presentation. So on top of the three elements, the aforementioned elements, we have now the detect and avoid solution, which is still considered just an aid. So is not supporting is not a mandatory equipment at the moment, but its roadmap aims to get a ATSO, so an European Technical Standard Order, which is leading to simplified the future operations and mainly to progressively reducing the need for a case-by-case safety risk assessment. That is hampering the possibility to be very flexible in the US missions. Going on focusing on the experience, on the Leonardo experience, on the civil side, we have been flying for over 1,200 flight hours during a specific contract for maritime surveillance and search and rescue over the Mediterranean Sea. And operations were authorized through by ENAC based on a risk assessment process that I mentioned before, so the specific operation risk assessment methodology, which led also to an evaluation and a classification of the risk, classified SAIL-3 in the specific case from Lampedusa. There was also a specific measures from what concerns the flight areas management, including holding points for the Falco in order to avoid any kind of risk of interference with civil and HAMS traffics, and resume as soon as possible the surveillance mission. In the case of military, we are relying on the military national authority for the permit to fly of the experimental flying test of our Falco Explorer. This particular UAV is much bigger than the one we saw before. We are talking about 20 meters wingspan, 1.3 ton of maximum takeoff weight, and also all the avionic and airframe and all the elements designed in accordance with the STANAG 4671 edition 3 in order to get a full type certification in the future. So this UAV is currently still deployed in Trapani and has performed so far 150 hours of flying tests. And as part of these flying test activities, a dedicated flying campaign is foreseen during this summer to validate the first detect and avoid prototype solution that I was mentioned before, and Antonio Vento will explain in a minute. So still relying on these limitations, but supporting the future. And that's what we are doing towards the implementation of a new detect and avoid system. So now Antonio will better explain why we are investing so much effort as Italy, as Europe, and as industries on this technology, and why we need a European technology on that, considering the operational environment very specific of Europe, and also other limitations of implementing other solution alternative to a European.
Okay. Thank you, Fabio. Thank you, Fabio, for your introduction. So, as we said before, detect and avoid is the very key enabler for ARPAS accommodation, and in the future, once we will productify the detect and avoid for the overall integration of ARPAS in the airspace. But what is a detect and avoid, and why is it needed on ARPAS? Basically, ICAO Annex 10 gives some high-level requirements about the detect and avoid that has, as a minimum, provide the remote pilot with all the instruments and all the aids in order to fulfill the responsibilities, in order to avoid collision with other traffic, according to the rules of the air which are defined in the ICAO Annex 2. But in order to be fully integrated with the other traffic, this solution, every solution must be interoperable with all the other collision avoidance system. So for instance, with aircraft which are TCAS equipped, and shall be capable of identify in the airspace in which the aircraft is intended to fly all kind of threats. So not only near threats, but also potential threats. And this classification is important because the degree of attention, the level of attention and the responsibility of the pilot changes in the different situation. Also must provide not only maneuver capabilities to the pilot, but also in advance proper alerts in order to intercept as soon as possible any kind of threat into the traffic. Without going into any technical detail, but as a very high-level overview, the minimum capabilities needed for a detect and avoid system are, as a very minimum, the capability to sense, so traffic surveillance of both cooperative and non-cooperative aircraft, and provide the pilot with remain well clear and collision avoidance function, where collision avoidance is the very last tool, is the very last function in if any safety barrier before has been broken. So the detect and avoid system must come into place and perform automatic maneuver of collision avoidance to avoid the traffic. In this framework, a key role is represented by the UDAS project mentioned before by Fabio. UDAS is the acronym for European Detect and Avoid System. It's a project involving 11 companies from 5 states, as you see above: Italy, Sweden, France, Spain, and Germany, plus the collaboration of key stakeholders such as EASA, Eurocae, and Eurocontrol. This project is co-financed by both European Commission and MODs of the 5 member states. So there is a key participation and a key role of the MOD in the definition of everything relates with this detect and avoid system in Europe. The goal of the overall project is to develop and validate a solution which is 100% European, so not subject to any control or restriction by a third country. And the main goals overall are not only to develop a solution which allows RPAS integration into all airspace class A to G for performing IFR flights, but also to define and validate the set of standards which will drive the accommodation and the integration of any kind of AirPass into the airspace. So basically, we are not only developing a set of equipment, but we are defining the basis of the standard and the regulation which will cover in the present and in the future, furthermore, the insertion of AirPass into the airspace. The overall duration of UDAS project is 8 years, as you can see in this second and third box, from 2020 to 2028. We are not starting from scratch in UDAS because UDAS inherits the experience from other research projects done in the past. The main one was MIDCAS. As you see in this slide, UDAS has a roadmap of 8 years. Now we are close to complete the first phase, where we have developed a prototype solution which suits 2 different classes of aircraft: tactical UAV, which Falco Explorer will be the first platform hosting this prototype solution for tactical UAV, and mail class, so something that could fit in the future also the Eurodrone. And we are based on this design that we have done. This design has been the basis for the updates of the standards in Eurocae, such as OSED and MASPs, which have been already published, and furthermore the MOPS, which is supposed to be drafted by the end of this year. And the project will be closed with a wide validation activity at any level, which will involve not only an operational validation in real-time simulation environment, involving also air traffic control operator, but also validation on flights for instance, in our platform Falco Explorer, as Fabio mentioned before. So the goal at the end of this project will be to have a solution with a technological readiness level 6 to 7 and a basis of standards, OSED MASPs, and hopefully MOPs. In continuity with UDAS 1, by the end of this year, we should start with the second phase of UDAS, the so-called UDAS 2, other 4 years, where the goal is a productification of this solution and the definition of the certification basis with EASA. And through the validation activities that we are going to complete at the end of UDAS 1, that will be the basis for the updates of the standard in EuroCAE. So the overall goal at the end of these 8 years is to have a solution with a high technological readiness level equal to 8, a solid base of standards, not only the requirements, but also the validation results, and also to agree upon a certifiable solution together with the EASA. And this is the overall goal of the project. And as we said before, we are acting a key role in this project, and we will do the same also in UDAS 2.
Thank you very much for hosting us. And so, in a nutshell, you see that it's a quite long journey towards having free UAS fully integrated in the airspace, flexibly flying. But we are very supportive to that, and I think we are in a good shape as Italian industrial, military, and civil authorities' involvement into this task.